Okay, so what are the characteristics of a discrete probability distribution? In a discrete probability distribution, number one, the random variable, this is usually just X. They use it to represent the outcome of any particular event. The random variable can only take on discrete numerical values. It cannot be a categorical value like boy or girl, yes or no, green or pink. It has to be a numerical value, and it has to be a discrete value such as integers. You have to be able to count how many values there are, and you need to be able to distinguish between them so that, for instance, it's not something continuous like how long does it take to do something, because that could be a continuous amount of time. But a discrete value, rather, is going to have probably an integer value like 1, 2, 3, 4. Each instance of an event would have to have some kind of a probability. And the probabilities total of every single possible outcome have to be exactly 1, which is the same as the 100%. You roll a die. You can only land on 1, 2, 3, 4, 5, or 6. So those are discrete, they are exact, and there's nothing else that it could be. The probabilities of each of these events has to be somewhere between 0 and 1 inclusive. So it could be that it absolutely cannot be this one, which would be 0%, or it will absolutely turn out to be this one, 100%, or generally something in between. When we talk about probability distributions, we're usually interested in the mean, the standard deviation, or something that involves those, like the range rule of thumb. The mean for a probability distribution is calculated much like that of a frequency distribution. You know, with a frequency distribution, you take each possible outcome times the number of times it happened. That is basically going to give you the weight, because the more often it happened, the more it contributes to the mean. In a probability distribution, rather than the number of times it occurs, we multiply it by the probability of that occurring. So to get the mean for a probability distribution, you take each possible X, each possible outcome, times the likelihood it'll happen. The variance is going to be the sum of the difference between each X value and the average, sound familiar, squared to make sure it's positive, times the probability. Or another way that they sometimes write the formula, where if you're going to do it manually, it's much easier to calculate, is to square each X value, each possible outcome, times its probability, get the sum of those, and then subtract the mean squared, which will come out to be the same. This first version is easier to relate to the way we typically calculate the variance in a frequency distribution. And of course, your standard deviation, sigma, is the square root of the variance squared, or the variance. So it's the same thing, except taking the square root of it. However, we're going to typically be using StatCrunch to do all of our calculations for us. So now that you know the formulas, let's talk about the easy way to do it. So let's look at one of the homework problems. 5 males with an X-linked genetic order have 1 child each. Now, you know, if it's an X-linked genetic order, that it's going to be recessive And these males are not actually going to show any symptoms of this genetic disorder. Anyway, the random variable X is the number of children among the 5 who inherit the X-linked genetic disorder. Determine whether a probability distribution is given. If a probability distribution is given, find its mean and standard deviation. If it's not a probability distribution, then you can't do that. Okay, one way to determine quickly whether this is a probability distribution, remember that it has to have discrete values for the X. Got that? All of the probabilities have to be between 0 and 1, really easy to tell at a glance. But also all the probabilities have to add up to exactly 1. Okay, we could do that with a calculator. We can also do that in StatCrunch. If I open this in StatCrunch, I can get the sum of this column by going Data, Compute, Expression, Build. I'm going to select Sum. So on the functions, I'm going to come all the way down to the S's and locate sum. Little ways more, there we go. I'm going to add that function. I'm going to click on the P of X title, because if you look, well, I'll show you when we go back to it. Because P of X, I'm going to add that column in here. This will give me the sum of, this has got quotes around it to indicate that it is a title rather than just a number. But if I hit OK, compute, see here's my P of X. The sum of P of X is 1. So this is a probability distribution. The X values are discrete values. The probabilities are between 0 and 1, and the sum of the probabilities is 1. Now, the problem is asking me to find the standard deviation and the mean for these values, or for the whole thing. Let's do that this way. If I click Stat, Calculator, and then we're going to do binomial in the next section, but for right now, we want to come all the way down here to Custom. The values here are in the column with X. The weights are basically the probabilities. So I'm going to hit, the values are in X, the weights are in P of X. I'm going to hit Compute. It immediately gives me a graph. I can pull this over so that I can split the screen between them so that clicking on one side doesn't clear out the other. So the first question here was just, does it show a probability distribution? Yes, we've decided that's an affirmative. Find the mean. Well, the mean is right over here. So here's the mean. Here's the standard deviation. So for the mean, I just come right over here and type in the 2.5. And then it comes up and asks for the standard deviation. And I will enter, let's see, 1 decimal place. Make sure you double check on how many decimal places this needs, because that's actually the hardest thing, is just to remember to round it off to the right spot. Check answer. Fantastic. Here's another problem where they're asking us to use the range rule of thumb to identify the range of values that are not significant. You've always got your mean average. The range rule of thumb says that if you go out 2 standard deviations, so here's 1, here's 2 in the positive direction, here's 1, here's 2 in the negative direction. If you go 2 standard deviations out from the mean, everything between those is not significant. The upper end is going to be significantly high. And the lower end is significantly low. So typically we're interested when we do statistics in finding stuff that is significantly high or significantly low. That's what they do when they're doing scientific research. But in this case, they're asking us to use the range rule of thumb to identify the range of values that are not significant. So the maximum value in this range is how many girls. The accompanying table describes results from groups of 10 births with 10 different sets of parents. The random variable X represents the number of girls among the 10 children. Use the range rule of thumb to determine whether 1 girl in 10 births is a significantly low number of girls. Obviously, that would have to be low, not high. So if we look at the table, what we want to do is load this into StatCrunch. So I'm going to click on this. I'm going to clear the screen. I am going to move this over so that I can see both the problem and the data at the same time. And since this data is repeated over on the other side, I don't need this anymore. So the maximum value in the range would be mu plus 2 standard deviations. Where do we get the mu and the standard deviations? Well, if I hit Stat, Calculators, come down to Custom, my variable is in X column, my weight is in the probability column, Compute. Here's my mean, here's my standard deviation. Here and here. So I'm going to go ahead and use my calculator to get mu plus 2 standard deviations. So I'm going to look at 5.085 plus 2 times 1.765. I want to make sure I get enough decimals to counteract any possibility of having a rounding error. So I'm going to go ahead and put the whole thing in. My calculator gives me a result of 8.6153. Okay, this only wants 1 decimal place, so I don't have to go any farther. Let me enter 8.6. Good job. The minimum value will be mu minus 2 standard deviations. Of course, that's going to be 5.085 minus 2 times 1.765. This is only going 1 decimal place. I'm sure carrying this out 3 should be plenty. Calculator gives me 1.555. 1 decimal place This tells me to round it up, so 1.6. Well done. Based on the result, is 1 girl in 10 births a significantly low number of girls? Okay, the non-significant values we've got our mu in the middle is 5.1 basically. If we go up to standard deviations, we've got 8.6. If we go down to standard deviations, we've got 1.6. 1 girl would be down here, which would be in the significantly low range. So yes, 1 girl is significantly low because 1 girl is above the range of values or below the range of values. Well, to be in the significantly low range, it has to be below the range of values. Well done. Another type of problem that we run into is where they will ask us what the probability is of either a specific X value or perhaps the probability of that X value or less than that, or that X value and more than that. Or perhaps they'll say more than that X value. Well, let's see how we can do this in StatCrunch. The accompanying table describes the random variable X, the number of adults in groups of 5 who reported sleepwalking. Complete parts A through D below. Click the icon. Here's our probability distribution. There was a 15.7% that out of every group of 5, no one would report sleepwalking. There was a 0.385 or 38.5% probability that within a group of 5, 1 person reported sleepwalking. About a 30% chance that 2 people would say they had sleepwalked. Only a 0.007 probability that all 5 would say that they knew they had done sleepwalking. That is less than 1%, so that's going to be significantly low, folks. As a matter of fact, the 4 having exactly, these are for exactly 4 people say that they reported sleepwalking is going to be significantly low. So find the probability of getting exactly 4 sleepwalkers among 5 adults. If I put this in to get that graph back, so I go Stat, Calculator, Custom, the variables are in X, probabilities are the weight, compute. And you see that the highest number occurs if 1 out of 5 reports sleepwalking. The next highest is that you might get 2 out of the 5 report sleepwalking. After that, you're more likely to have nobody than 3 or 4. Very low probability of having 5. If we want to know exactly 4, then I can put equals 4, and that is, of course, going to give me exactly the same thing that was in the table. Let me put the table back. Exactly 4 is 0.023. That is the probability that we would have exactly 4. But what I want to show you is also what happens if you get more or less than that. So let me put this in, 0.023. Excellent. Now, find the probability of getting 4 or more sleepwalkers. 4 or more would include 4 and 5. You could actually do this since it's discrete values and they there's no 4.5 going to happen. You could actually do this by adding the probabilities for 4 and 5 together. Or we could change this. 4 or more would include the 4 and any numbers larger than 4. So I can put it as x is greater than or equal to 4, and now I have 0.03. You notice the probability of 4 or more is higher than the probability of exactly 4. So 0.03. Which probability is relevant for determining whether 4 is a significantly high number of sleepwalkers among 5 adults? To be significantly high, it has to be that the total probability of that and anything above that, because we're talking about high, that and anything above that gives a total sum of more than 5%. Or to be significantly low, it has to be that the total sum of that or less than that is going to be more than 5%. So since this is less than 3%, this is significantly high, but they're asking whether it's more important to look at the numbers for exactly 4 or 4 or more. And what matters is the 4 or more. So since the probability of getting 4 sleepwalkers is the result from part A, that's not what they're looking for. It's actually part B is the answer. Since the probability of getting fewer than 4, no, well, is the complement. What else we have? The probability of getting 5 includes getting 4. I believe that's going to be our answer. Excellent. Love these last questions because it tests your understanding of it. And sometimes it's worded really strangely, so you have to really read it word for word. A lot of times there are two choices that are extremely close, and they may differ by one word. One of them is going to have a blah, 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 is blah, 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 and the other one's going to have a blah, 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 is not blah, blah, blah. You got to read the whole entire thing word for word. So those are always fun. So this is how StatCrunch can do this for us. It's lovely of them to have this, and it sure makes things a lot easier. Enjoy. Talk to you later.